Welcome, math lovers, to another problem of our series 100 Problems Around the World. Today we have a very beautiful problem and, in my opinion, even a difficult one. So please bear with me during the solution of this problem. We are going to Germany this time for the Germany Math Olympiad of 2025. This is their final phase. So this is their, let's say, national phase for grade 12, which should be students up to 18 years old. So the condition of the problem is as follows. If a, b, c are positive real numbers, prove that a to the fifth divided by b squared plus b divided by c plus c cubed divided by a squared is greater than 2a. Now the first difficulty we notice is that the inequality is not symmetrical. So let's see some possible solutions of the problem. I will share now one with you, and if someone has any other solution, please let me know in the comments. So we rewrite the given conditions of the problem, and we are asked to prove this inequality. So as I said, the inequality is not symmetrical, so we have to find some ways of solving it. But as always, given that ABC are positive real numbers, AMGM is the first thing that comes to mind for the solution of this kind of problem. Now, in order to be, let's say, for us to be possible to solve this problem, let's reason as we did for the Canadian Math Olympiad, and let's rewrite the left-hand side in another form. So the given left-hand side is actually equal to 3a to the fifth divided by 3b squared plus 6b divided by 6c plus 2c cubed divided by 2a squared. Now, I will show you the importance of why this is very, very crucial for our problem. Allora, we will have that now, given that ABC are positive real numbers, we can apply AMGM on the left hand side new form, let's say. But in order to do so, we will, let's say, divide this in 3 factors. The first term in 3 factors, the second term in 6 factors, and the third term in 2 factors. Now, from AMGM, these now we have 11 factors. This will be, we can apply AMGM because ABC are positive real numbers, will be greater or equal to 11 times square root with index 11 of the given expressions inside the square root. Now, this side over here, we know that is greater or equal to this term over here. But now let's see what this term actually has. Because if we redo the calculation, if we regroup all the indexes of all the terms ABC, we will get that the right hand side over here is equal to 11 times square root of with index 11 of a to the 15th times b to the 6th times c to the 6th divided by 3 to the 3rd times 6 to the 6th times 2 squared times a to the 4th times b to the 6th times c to the 6th. Now we do the calculations over here. We will do the, let's say, we reduce the equal terms, and we will get that this expression is equal to 11 times square root with index 11 of this expression over here, which in this case is equal to this other expression, and we can say that this expression over here is greater than 2a. Now, given that our left hand side is equal to this, and this is greater or equal to this expression, and we just saw with this line of calculations that this expression itself is greater than 2a, we could say that our expression is greater than 2a. But in order to take it, let's say, for good, we first should prove this very small inequality over here. And in order to do that, in this inequality over here, we will see that we will reduce a on both sides, and we will take these terms on the right hand side. And we need to prove that 11 is greater than 2 times 3 to the power 9 divided by 11 times 2 to the power 8 divided by 11. Or if we raise to the 11th power both sides, we need to prove that 11 to the power 11 is greater than 2 to the power 11 times 3 to the power of 9 times 2 to the power of 8. However, we see that this expression over here, it is equal to 12 to the power 11. So we multiply and divide by 3 squared this factor and by 2 to the third this factor, and we will have that this expression is equal to 12 to the power 11 divided by 72, which is obviously smaller than 11 to the power 11th, because this expression over here is smaller than 72, because 12 to the power 11 divided by 11 to the power 11 is approximately 2.64, which is much smaller than 72. So what did we do in order to go back and to reason why we have proved this inequality? We just proved that, let's say, initially our left hand side is equal to this term. This term can be rewritten in this condition, which by AMGM is greater than this expression over here. Now this expression over here, we saw that actually it is greater than 2a. So we can directly say that this term over here is greater than 2a, which is what we wanted to prove in this problem. In order to go through the last step of this inequality over here, we did the calculations which we have shown. So I know it is a little bit messy, but I didn't have any better solution this time than this solution. Please let me know in the comments if something better would work. Up to then, thank you for your time and hope to see you on our next videos. Bye.